Let's talk in some coarse language now. Now, what exactly is cross-origin resource sharing and why is it relevant when we look at web applications and hybrid mobile applications, as we have been doing in this specialization? As you understand, most web pages now pull in data from many different sites in order to construct the web page. Now, in order to impose a strict policy of access to resources from different sites, the same origin policy has been imposed by many browsers. We'll talk a little bit about that in more detail in the next few slides. But in the context of the frameworks that we have been discussing in this particular specialization, like Angular, Ionic, and NativeScript, many of these will involve scripts, JavaScript code that might have to access resources from different sites. And this is where the coarse problem crops up very easily. Let's see how we will address this issue in more detail in this lecture and the exercise that follows. I briefly alluded to the same origin policy when I started this lecture. Now, the same origin policy is a web app security model which restricts how a document or a script loaded from one origin will interact with resources from another origin. The purpose of this is to isolate potentially malicious documents. Now, obviously, when you have a web page that involves script, JavaScript code that might access resources from another location, potentially malicious code could be injected into your web page and thereby access a different origin than from where your web page is obtained. Now, that is the reason many browsers impose this same origin policy. Now, when we talk about same origin, how do we specify an origin? Now, in this context, an origin for any resource is defined by three tuples. First, the protocol that is used to access the resource. Secondly, the host name of the resource or the domain of that resource. And thirdly, the port number at which that resource is being accessed. So this is how we identify the origin of any resource. Resource in this case could be a HTML page, an image, JSON data being obtained from a REST API endpoint, and many more. To further elaborate on the same origin policy, let's look at an example. Suppose we have a web page that is loaded in from this site listed here, www.abc.com, and in a folder XYZ and the page .html being loaded in here. This page may involve links or even JavaScript code that might issue XML HTTP request to other resources on the web page. Now, in this case, if we try to access another URL, for example, the first one listed here, which obviously you see is from the same site, but from a different folder, this is acceptable because the origin, in this case, the protocol being used and the port number remains the same. So this is acceptable to access this resource. Similarly, in the second case, where we might have under several levels of subfolders a resource that is being accessed. But again, since the origin remains the same, this is acceptable. But let's look at the third example here. In this example, we see that we are trying to access a resource here with the HTTPS protocol, which obviously violates the same origin principle because we are using a different protocol to access that resource at this point. So that would be considered a failure in this case. The fourth case is where we are accessing a resource with a different port number. And the fifth case is where we are accessing a resource at a different host. Now, all these three would be marked as not valid or cannot be accessed under the same origin policy. So if you impose the same origin policy for access from, for example, your XML HTTP requests, then the last three would not be allowed in this case. But of course, there are many situations where a website designer may actually host resources on different sites, maybe at different domains, and still be able to pull in the data in order to construct the web page or to make the web application run or to make the hybrid mobile application run. So to accommodate these situations, the cross-origin request handling is a method that allows us to access these resources. So we consider a request to be a cross-origin request if you are trying to access a resource from a different domain or at a different port number or with a different protocol. So how do we accommodate situations where this is a legitimate access to a resource, but because of the same origin policy, your browser will refuse to load this resource? Now, this is where, as I mentioned, many browsers will restrict cross-origin HTTP requests, especially those that are initiated by XML HTTP requests or the fetch protocol for fetching data. These are relevant when we access these from within our JavaScript code. So in those circumstances, it makes sense to impose the same origin policy, but then we should have a way of working around the situation where a legitimate request can be issued. This is where the CORS approach, the cross-origin resource sharing approach, comes to our aid. So this CORS is a mechanism that enables web servers to perform cross-domain requests or cross-origin requests. So here, the browser and the server from where you're trying to fetch the resource will interact with each other and then come to an agreement saying that this access is acceptable and allowed. So once the agreement is reached, then this request can be allowed by your browser. So the browser and the server will interact with each other in order to determine if this access to this resource is an acceptable situation. So this is where a new set of HTTP headers were introduced into the HTTP reply messages coming in from the server side. These headers allow the servers to describe the set of origins that are permitted by the server to be accessed by the browser. And in turn, the browser realizes that these resource accesses are acceptable to be allowed, even though they are violating the same origin policy that we have seen earlier. So in this case, we have headers like, for example, access control allow origin, access control allow credentials, access control allow headers, access control allow methods, and a few others that the server uses to inform the browser, saying that this is an acceptable way of accessing the resource from the browser side. And when the browser sees these in the incoming reply message from the server side, the browser accepts and allows this cross-origin request to be performed. Now, this also means that the server should be set up to be able to respond with these header fields and the header information included in the reply message coming from the server side. Now, this is where we divide all the cross-origin requests into several categories. We have the first one being the simple cross-site requests. In simple cross-site requests, you might be using either the GET or the POST with the request body. But when you are using the POST, your request body should contain either application X www URL encoded or multi-part form data or text plain. Then it is treated as a simple cross-site request and no custom headers will be allowed in this case. So in this case, it is acceptable for the server to inform the client saying this is allowed, and the browser should allow such requests. So for example, for widely accessed resources, like for example, if you perform a GET request to a server in order to fetch the data in order to construct the UI, then maybe the GET request is acceptable no matter which origin that request is originating from. So in that case, your server will reply to the client saying access control allow origin with the wildcard star here, meaning that any origin that originates the request is acceptable and the browser should allow the request to be performed to the server. Now, you can also restrict the access to the origin. In this case, you can specifically say that if the origin is a particular site, then it is acceptable to service this request. So the browser sees that this particular origin or sending requests with this particular origin set in the request is acceptable and will allow the cross-origin request. So you can control the way the origin is specified in the request message coming from the client side. So the server is able to accept such requests. Certain other requests would be under the category of pre-flighted requests. In the pre-flighted requests, you expect that before the client sends the actual request, the client will send a pre-flight request, meaning that it contacts the server to obtain information from the server before the actual request is issued. This is specifically the case where you issue put and delete requests, because put and delete requests might cause changes on the server side. And so any method that causes side effects on the server's data, like the put and the delete requests, are specially mandated to follow the pre-flight approach. In the pre-flight approach, the idea is that the client will first send an HTTP options request to the server side, and in reply to that options request message from the client side, the server will respond with the corresponding access control allow headers, access control allow origin, and access control allow credentials header information in the reply to an options message. Thereafter, the client will decide whether it can issue the cross-origin request or not based upon the response to the options pre-flight request that the client sends. So this is where you have to go through two steps before your request can be allowed and serviced by the server side. A third category of CORS requests would be what are called as credential requests, where you expect the client to include credentials in the header of the request message. So the requests that are accompanied by cookies, for example, for recognizing the session on the server side, or some kind of HTTP authentication information in the authorization header in the request message. So in this case, the server needs to respond with access control allow credentials true to the client side. So in this case, the server will respond with this, and then the client will be allowed to send the credentials information in the incoming request from the client side. Now, in this case, the access control allow origin is not allowed to have the wildcard, the star in the reply message. It is expected to explicitly specify the origin from to which the request can be initiated. Now, obviously, we can implement much of the work that we need to do on the server side by implementing our own middleware if we so choose to handle the CORS related replies from the server side. It's very straightforward, as we have seen in the code that we have implemented. Of course, that is one way of handling CORS related replies from the server side. But fortunately, we have a specific CORS node module that is designed to handle these very kind of work that the server needs to do to meet the CORS requirements. So the CORS node module allows us to configure the CORS on the server side, including specifying origin information, whether credentials would be accepted, and many other pieces of information, such that you can configure the server to be able to handle CORS related replies that it needs to give to the browser in response to the request message. To install the CORS node module, obviously you say npm install CORS, and then configure the CORS middleware within your Express application. The CORS module itself provides a very simple way of enabling CORS. You can simply include app use CORS and with empty brackets, and that essentially means that you're opening up your server and it'll reply with the access control allow origin with the wildcard star to every incoming request. Now, but when you are configuring your server, you may want more control over that. So that is where we can specify additional options for the CORS. And not only that, you can impose CORS handling differently for different routes within your server side. So as we will see in the exercise, we will impose different CORS requirements on the different routes on our server side. And this is all configured by using various configuration options that the CORS node module supports for us. So using the CORS node module, it is very easy to set up your server to handle any cross-origin requests coming in from your client side, and then respond with the appropriate header information to the client side with the appropriate CORS headers in the reply message from the server side. With this quick understanding of CORS, and I'm sure you have more questions at this point than answers from this lecture, but if you would like to read a lot more details about CORS, I have provided you additional resources in the end of this lesson, which enable you to read more about CORS itself. But from the perspective of this course, we would like to configure our Express application that we have been developing so far to handle CORS related matters on the server side. So moving on to the exercise, we will install the CORS npm module and then configure it on various routes within our Express server.